This is a training module for the Altera Cyclone II FPGA. Welcome to this module on the Cyclone II family FPGA from Altera. The module overviews the major features of the Cyclone II family FPGA. Programmable logic is loosely defined as a device with configurable logic and flip-flops linked together with programmable resources that control the interconnections. User programmable memory cells control and define the function that the logic performs and how the various logic functions are interconnected. Thus, a wide range of sequential circuits can be implemented on a low-cost PLD. Though various devices use different architectures, all are based on this fundamental idea. FPGAs have gained rapid acceptance over the past decade because users can apply them to a wide range of applications. Random logic, integrating multiple SPLDs, device controllers, communication, encoding and filtering, small to medium-sized systems with SRAM blocks, and many more. Another interesting FPGA application is prototyping designs to be implemented in gate arrays by using one or more large FPGAs. An application only beginning development is the use of FPGAs as custom computing machines. This involves using the programmable parts to execute software rather than compiling the software for execution on a regular CPU. Altera understands programmable devices are part of a bigger picture, and that true design success requires an array of other tools. To that end, Altera complements the complex programmable logic devices, CPLDs, and field programmable gate arrays, FPGAs, with sophisticated software tools, pre-verified and configurable intellectual property IP cores, a software core processor, Nios 2, development kits, and reference designs. Our comprehensive solution portfolios result in a faster, simplified design process and, in turn, faster time to market and lower development costs. With Altera solutions, you can undertake your design, confident that you will be able to meet your unique application design goals. Following the immensely successful first-generation Cyclone device family, Altera Cyclone II FPGAs extend the low-cost FPGA density range to 68,416 logic elements and provide up to 622 usable I/O pins and up to 1.1 megabits of embedded memory. Cyclone II FPGAs are manufactured on 300mm wafers using TSMC's 90nm process to ensure rapid availability and low cost. By minimizing silicon area, Cyclone II devices can support complex digital systems on a single chip at a cost that rivals that of ASICs. Altera's low-cost FPGAs, Cyclone II FPGAs, offer high performance and the low power consumption. Altera Cyclone II FPGAs extend the low-cost FPGA density range to 68,416 logic elements and provide up to 622 usable I/O pins and up to 1.1 megabits of embedded memory. Embedded multiplier block can implement up to either two 9x9-bit multipliers or one 18x18-bit multiplier with up to 250 MHz performance. Embedded multipliers are arranged in columns across the device. Cyclone II devices support a broad range of external memory interfaces such as SDR, SDR-RAM, DDR, SDRAM, DDR2, SDRAM, and QDR2 SRAM. Dedicated clock delay control circuitry allows Cyclone II devices to interface with an external memory device at clock speeds up to 167 MHz or 333 megabits per second for DDR and DDR2 SDRAM devices, and 160 megahertz or 667 megabits per second for QDR2 SRAM devices. Each Cyclone II device has up to 4 PLLs supporting advanced capabilities such as clock switchover and programmable switchover. These PLLs offer clock multiplication and division, phase shifting, and programmable duty cycle, and can be used to minimize clock delay and clock skew, and to reduce or adjust clock to out and setup times. Altera Cyclone II FPGAs extend the low-cost FPGA density range to 68,416 logic elements and provide up to 622 usable I/O pins and up to 1.1 megabits of embedded memory. Cyclone II devices include a powerful FPGA feature set optimized for low-cost applications, including a wide range of density, memory, embedded multiplier, and packaging options. Cyclone II devices support a wide range of common external memory interfaces and I/O protocols required in low-cost applications. Vertical migration means that you can migrate to devices whose dedicated pins, configuration pins, and power pins are the same for a given package across device densities. Cyclone II devices support vertical migration within the same package. For example, you can migrate between the EP2C35, EPC50, and EP2C70 devices in the 672-pin fine-line BGA package. Cyclone II devices support the Nios 2 embedded processor, which allows to implement custom-fit embedded processing solutions. Cyclone II devices can also expand the peripheral set, memory, I/O, or performance of embedded processors. Single or multiple Nios 2 embedded processors can be designed into a Cyclone II device to provide additional co-processing power or even replace existing embedded processors in your system. Using Cyclone II and Nios 2 together allow for the low-cost, high-performance embedded processing solutions which allow you to extend your product's life cycle and improve time to market over standard product solutions. Nios and Nios 2 are the soft process IP solutions for Altera for embedded applications. The table demonstrates the resource utilization or logic element usage summary for Nios and Nios 2 embedded processor with Cyclone II FPGAs. Nios 2 processor adds the advantage in better performance with less silicon utilization and comparatively low cost. Altera's Quartus 2 design software supports all Cyclone II family devices. Quartus 2 software has full integrity with advanced tools such as SOPC Builder and DSP Builder for embedded and DSP applications respectively. Cyclone II devices contain a two-dimensional row and column-based architecture to implement custom logic. Column and row interconnects of varying speeds provide signal interconnections between logic array blocks, embedded memory blocks, and embedded multipliers. The logic array consists of LABs with 16 logic elements in each LAB. An LE is a small unit of logic providing efficient implementation of user logic functions. LABs are grouped into rows and columns across the device. Cyclone II devices range in density from 4,608 to 68,416 LEs. Each LAB consists of 16 LEs, LAB control signals, LE carrier chains, registry chains, and local interconnect. From high-speed backplane applications to high-end switch boxes, low-voltage differential signaling (LVDS) is the technology of choice. LVDS is a low-voltage differential signaling standard, allowing higher noise immunity than single-ended I/O technologies. Its low-voltage swing allows for high-speed data rate transfers, low power consumption, and reduced electromagnetic interference. Cyclone II device IOEs contain a bidirectional I/O buffer and 3 registers for complete embedded bidirectional signal data rate transfer. The IOE contains 1 input register, 1 output register, and 1 output enable register. You can use the input registers for fast setup times and output registers for fast clock to output times. Additionally, you can use the output enable register for fast clock to output enable timing. The IOEs are located in I/O blocks around the periphery of the Cyclone II device. There are up to 5 IOEs per block and I/O block, and up to 4 IOEs per column I/O block. The row I/O blocks drive row, column, or direct link interconnects. The column I/O blocks drive column interconnects. The output buffer for each Cyclone II device I/O pin has a programmable drive strength control for certain I/O standards. The LV-TTL, LV-CMOS, SSTL-2 Class 1 and 2, SSTL-18 Class 1 and 2, HSTL-18 Class 1 and 2, and HSTL-1.5 Class 1 and 2 standards have several levels of drive strength that you can control. Using minimum settings provided, signal slew rate control to reduce system noise and signal overshoot. The table shows the possible settings for the I/O standards with drive strength control. PCI Express is rapidly establishing itself as the successor to PCI. It provides high performance, increased flexibility, and scalability for next-generation systems without increasing costs, all while maintaining software compatibility with existing PCI applications. Now you can easily design high-volume, low-cost PCI Express solutions today with Cyclone II FPGA EP2 C15 or larger. Cyclone II devices offer hot socketing, also known as hot plug-in, hot insertion, or hot swap, and power sequencing support without the use of any external devices. You can insert or remove a Cyclone II board in a system during system operation without causing undesirable effects to the board or to the running system bus. The hot socketing feature lessens the board design difficulty when using Cyclone II devices on printed circuit boards that also contain a mixture of 3.3, 2.5, 1.8, and 1.5 volt devices. With the Cyclone II hot socketing feature, you no longer need to ensure a proper power-up sequence for each device on the board. The I/O pins on the Cyclone II device are grouped together into I/O banks, and each bank has a separate power bus. EP2C5 and EP2C8 devices have 4 I/O banks, while EP2C20 and EP2C70 devices have 8 I/O banks. Each device I/O pin is associated with 1 I/O bank. To accommodate voltage referenced I/O standards, each Cyclone II I/O bank has a V reference bus. Each bank in EP2C5, EP2C8, EP2C15, EP2C20, EP2C35, and EP2C50 devices support 2 VREF pins, and each bank of EP2C70 supports 4 VREF pins. Cyclone II devices have up to 4 phase lock loops, PLLs, that provide robust clock management and synthesis for device clock management, external system clock management, and I/O interfaces. Cyclone II PLLs are versatile and can be used as a zero delay buffer, a jitter attenuator, a low skew fan-out buffer, or a frequency synthesizer. Cyclone II PLLs support 4 clock feedback modes: normal mode, zero delay buffer mode, no compensation mode, and source synchronous mode. Cyclone II PLLs do not have support for external feedback mode. All the supported clock feedback modes allow for multiplication and division, phase shifting, and programmable duty cycle. In the active serial configuration scheme, Cyclone II devices are configured using a serial configuration device. These configuration devices are low-cost devices with non-volatile memory that feature a simple 4-pin interface and a small form factor. These features make serial configuration devices an ideal low-cost configuration solution. This table shows the approximate uncompressed configuration file sizes for Cyclone II devices. To calculate the amount of storage space required for multiple device configurations, add the file size of each device together. Cyclone II devices include a powerful FPGA feature set optimized for low-cost applications, including a wide range of density, memory, embedded multiplier, and packaging options. The low-cost and optimized feature set of the Cyclone II FPGAs make them ideal solutions for a wide array of automotive, consumer, communications, video processing, test and measurement, and other end market solutions.